this happy Monday and happy June. Today is June 1st. How exciting. I hope that you guys got a chance to go outside and enjoy the beautiful weather. And welcome back to science for today. You're on step 1, which is watching this video. Good job so far. So the first thing we're going to do is go over some of the work from Friday, and then I'm going to explain today's assignment. So far we have looked, first of all, we have figured out what fossils are. We've seen how fossils can possibly be used as evidence of common ancestry. We've seen fossil progressions in different organisms and how scientists have interpreted the fossil record to see, progressions that could have happened. We looked at the Tiktaalik, we looked at whales, we looked at horses to kind of see when scientists find these things in the earth, how do they then create this story of what could have happened based on evidence. Again, kind of like a crime scene. When there's evidence left behind in a crime scene, scientists look at it, they interpret it, and they try and figure out what may have happened based on what's left behind. So that's exactly what scientists are trying to do with these fossils, to figure out evidence of common ancestry and to kind of learn about things that have been around that we might not have been able to see. So hopefully you're enjoying it so far. I know fossils are really interesting for me, so hopefully you're finding them interesting as well. So on Friday, I just gave you some kind of statements about both the whale, Tiktaalik, and then general statements, and then you had to kind of sort them in a way that made sense to you. I wanted to do this to give you an opportunity to kind of review what we've learned so far, but also to see what both of them have in common, because I know sometimes when we look at a Tiktaalik and then we look at a whale, it can be hard to put those together and then also apply those ideas to other things. So I want to make sure that that's pretty clear. So whales versus Tiktaalik. So whales are much more recent. Still millions of years old, but 48 million years ago to modern day, whereas the Tiktaalik was 385 million years ago. Whales, we learned actually about vestigial structures. You can practice saying that word, vestigial, which were the small leg bones that they have, even though whales don't have legs. So they do have leg bones. If you went on to that E-level, you could have seen some vestigial structures that humans have. So if you didn't get a chance to check that out, I highly recommend it because it's super cool to see what organs or bones humans have that we don't actually have a purpose for. So the whale also showed a land to sea transition, whereas the Tiktaalik did a sea to land transition. So that's how they were a little bit different. And then the whales live in water, but they actually have lungs and they breathe air and they give birth to live young. So they're mammals just like us, which is very interesting. Even though they live in the water, you would think they'd have gills and not be mammals, but they are, which is really cool. They also have smaller hind legs in newer fossils, and bigger legs in older fossils. The original whale, ancestor whale, I think they compared to be like a small dog. So the Tiktaalik, on the other hand, big characteristics where the head shape went from tall to flat. There are larger legs in newer fossils and smaller legs in older fossils because obviously it went from a fish sort of creature that probably didn't have leg bones or had very small leg bones to a land animal that had to have those hind legs. So something that they both actually share in common is that fossils are used as evidence of common ancestry. So that we learned about both the Tiktaalik and whale based on their fossils. They both show evidence of moving from one environment to another. So you guys had really great questions, really great wonderings about why they might have moved from one environment to the other. So that'd be something I'd be interested in exploring. And then also fossils can be used to build a time progression showing a progression over time. So you can kind of see this story over time based on where the fossils are found and also based on the small changes over time. Vestigial structures can be used as evidence of common ancestry. So whether that be in whales or humans or other organisms, if there are vestigial structures, you can start to think, well, why might that organism have really small leg bones even though it doesn't have a leg? Oh, maybe their ancestor had legs. So that's pretty interesting too. So today, we're going to continue on this journey of how do scientists figure out if organisms are related and what do they actually look for as evidence of common ancestry. And we're going to be looking at something new, not vestigial structures, but we're actually going to be looking at something called homologous structures. So you can practice saying that, homologous structures. So what you're going to do is you're going to go to this website. And you are going to, as you explore the website, answer some of these questions in today's Google form. So it's going to ask, what is homology, also known as homologous structures. You're going to click on some limbs that aren't like the others. Tell me what criteria you use to determine which one of these things is not like the other. And it kind of goes into those different homologous structures and some questions, and then goes back to our Tiktaalik example. So once you're done with that, you can turn it in. But something that you can do before that, just to kind of set you up, is that you can take a look at the bones of a human, whale, cat, bat, and bird and do some observations. What is similar between all of these organisms and their bones? What's different? And why might scientists believe they might have come from a common ancestor? Which ones do you think might be more related to one another? But really looking at similarities and differences between them. I think it's really easy to look at differences. I mean, the whale is really big, the human's skinnier, the cat is even smaller, the bat has really long, it looks like fingers almost. So really clear differences. So I think the one that's harder is looking actually for similarities. Like, what could a human, whale, cat, bat, and bird all have in common for their like arm bones? Another thing that you could do is, I like to, when I'm looking at them, kind of color them in to look for those similarities. So homologous structures are actually body parts with similar structures found in different species. So the word homologous is Greek. It means same, and logos means relationship. So in your own words, you are going to actually tell me what are homologous structures, and that again is in this Google form. I think it's the first question. What is a homology, also known as homologous structures? So by coloring them in, it's a little bit easier to see those similarities rather than those main differences. So hopefully this picture is helpful for you. So again, once you are done exploring this website and turning in the Google form, you're good for today. But today's goal is to look at homologous structures and think about how they might be evidence of common ancestry. So if you have any questions, let me know. I also just wanted to say that I know there's a lot of things going on in the world, and if you have any questions or you need someone to talk to about anything, just because we're not in school together, I'm always here for you. So you can always shoot me an email, reach out to me, reach out to any of your teachers. We'd be happy to talk to you because I know there's a lot going on. So if you ever just need someone to listen or someone to help or someone to talk to, just know that I'm always, always here for you. So I wish that we were together, but don't let that stop you from reaching out. Another thing is, over the summer, in the future, even if I'm not your teacher, I'm always here for you. So if you ever need anything, just let me know. But I hope you have a nice day. Send me emails if you need anything, and we will talk. All right. Bye, everybody.